All right, first problem. So mass, initial speed, constant net force, time, of course, in seconds, and final speed. All right, to get the net force, we gotta apply the Newton's second law. Well, in general, in general vectors, but in this situation, everything is about magnitude. So F equals 2 times acceleration, delta V delta t, and that's going to be final minus initial over time. At this point, we just have to get a calculator. What is it? 40 over 600. For 1 over 15. .067 newtons. Done. All right, very similar to a homework problem. 90, 30, 60, 90. And the force of gravity. Well, force of gravity action on the light is equal to 50 times about 10, 500 newtons. Or we could use kilograms, but of course the same force is action in this rope. So here we have 3 forces acting on this, well, nut. And as we remember, in a shorter rope, the force is stronger. In the longer rope, the force is weaker. And together, the net force must be equal to 0, equilibrium. So we can use components, but in this case, because we have a right angle triangle, let's actually make a triangle. So what we know is if we add these two forces, so actually the force of gravity must be vertical, so these two should combine somewhere here. So that's supposed to be force of gravity. That's supposed to be second force, tension. So that's supposed to be the angle between the forces, which is 90. And so somewhere here we should have 30 and 60. Well, to the right and then horizontal should give 60 to the right, and then horizontal shouldn't give 60. So that should be 30. That should be 60. That should be 30. Now we can solve it. So right triangle, hypotenuse, all angles, for example, TR has to be equal to the hypotenuse times opposite sine 60. Oops, what did I do? Make sure degrees. 500, so 400 newtons or 43.3 kilograms. 100 times. Actually, I want to use, well, sine again, but now 30, and that's 1/2, so 250 newtons, 25 kilograms, done. Okay, so kicking a ball from the ground. We did it in a class. The launch angle is 30 degrees, initial speed is 60. Goes up to maximum, falls down. That's X final or range. Yeah, 0. This is H max, maximum height. And same level for start and launch. T time up should be equal to time down. And right here at the top, velocity points to the right, which means at the top of the trajectory, the velocity should not have vertical component. We can use this fact. If you use the velocity equation, v equals v initial minus g times time. In this situation, 0 equals vy initial minus 10 times time up. And we can use this triangle, 60, 30, vy initial, vx, which is constant. So vy initial should be equal to hypotenuse times sine of 30, which is 30 meters per second. So 0 equals 30 minus 10 times time up. Time up equals 3 seconds. 3 seconds up, 3 seconds down. Total time is 6 seconds. And now to get maximum height. Well, it should be equal to vy initial times time up minus 10 times time up squared over 2, which is 30 times 6 minus 10 times 6 squared over 2. This is 180. This is oops, sorry. See, I made a mistake. That's time up. That's a total time. I should use time up, so let's correct it. And that's going to be 90, and that's going to be 90 over to 45 meters. So the range will be equal to Vx times time total. And Vx will be equal to hypotenuse times cosine 30 total times 6. So that's going to be, now I gotta use a calculator, 60 times 6 times cosine 30 degrees, 1.8 meters. Merry-go-round. Again, something similar to one of the lab homework problems. Circular motion. The radius of the motion 1.5, and the mass of this object, the child, 30 kilograms. And centripetal force n times centripetal acceleration, speed squared over the radius. Speed we can get by dividing distance over total time. And how do we get the speed? Well, there's always more than one way to do it, but 20 revolutions, we can count the revolutions. One revolution means distance traveled equals the circumference 2 pi r. I learned how to write better. Now we can do some algebra. Don't have to, yeah, can just plug the numbers in and done. But just for the sake of an experience, n squared, 2 squared, pi squared, close to 10, r squared, divided by time squared, divided by another r. So that's our final equation. R squared over r gives 1r left, time squared, numbers. Well, mass. Okay, let's put the mass at the end. 20 squared, 4 pi squared, 1.5 time. 4 minutes means 240 seconds. And that needs to be squared. Well, actually, that's how I want to do it. 20 times 4 times pi divided by 240 and then squared times, that's going to be 30 and 15, 45 equals. So 80 times 3.141596 equals divided by 240 equals this in case. So times 1.05 times 45. So we get about 49.5 newtons. Okay. Let's just check one more time. Mass, distance over time, distance, circumference times the number. Oh, of course I made a mistake. That's so 4 was 2 squared, so that's supposed to be 2 squared. So that's actually an easy fix. We just need to divide this number by 4 divided by 4. 12.4. All right, and the last problem is similar to, again, one of the class or lab homework problems. So we know it's about law of conservation of mechanical energy. Kinetic initial is 0. Potential initial is mg y initial. Naturally, we set the origin to the lowest location, and in that case y initial, the base of the ramp, belong to the same right triangle, so y initial over 2 equals tangent of 30, and Y initial equals 2 times tangent of 30, which is 1.16. Now, kinetic final, that's what we're looking for. Potential final will be equal to 0. And as we know, kinetic initial plus potential initial equals kinetic final plus potential final. And kinetic final will be equal to mgy initial, which is 200 times 10 times 1.16. So keep this number times 2000. 23 joules. Done.